Today we're going to explore variability in data distribution to better understand how a mean represents a set of data. Our objectives today are that we can interpret the mean of a data set as a typical value, and that we can compare and contrast two small data sets that have the same mean but differ in variability. Robert's family is planning to move to either New York City or San Francisco. Because temperature was one of the criteria he was going to use to form his opinion about where to move, he decided to investigate the temperature distributions for New York City and San Francisco. The table below gives the average, or mean, temperatures in degrees Fahrenheit for each month in the two cities. Pause the video for a moment and jot down anything you notice about this table. One thing I observe is that the average temperature of New York varies much more than the average temperature of San Francisco. New York has average temperatures as high as 85 degrees and as low as 39 degrees. Get a sheet of paper and pencil ready. We're going to walk through part 1 of your independent practice work. Pause the video here as you collect your supplies. The first problem instructs us to calculate the mean of the monthly average temperatures for each city. Let's do this first with New York's data. To find the mean monthly temperature, we're going to add all the values for each month and divide the total by the number of months. Here are all of our temperatures for each month. They total up to 756. We divide this total by the number of months we pulled data from. In this problem, we took the average temperatures of 12 months, so we'll divide by 12. This gives us a mean of 63. The average monthly temperature in New York is 63 degrees. What about San Francisco? Pause the video here as you calculate the mean of the monthly average temperatures for San Francisco. Unpause the video when you've finished. You should have found that the mean of San Francisco's monthly average temperatures was 64 degrees, just slightly higher than that of New York. Since Robert is using temperature as a deciding factor in where he moves, we could tell him that San Francisco averages slightly warmer weather than New York, but it doesn't appear to be significant when we compare the means. The mean can be misleading when comparing data sets like these, however. Here we have a dot plot of the table we were just looking at. The top dot plot shows all of the monthly average temperature data from New York, while the bottom dot plot shows all of the data points for San Francisco. Problem 3 instructs us to find the mean and mark it on the dot plot, similar to what we did in Lesson 7. Copy down these dot plots, then go ahead and take the means we calculated for both cities and add them to your dot plots. The means of the two cities are very similar, but look at the variability of the data points on each dot plot. Which dot plot has more variability, meaning a wider range of data values? New York has much more variability than San Francisco. New York has data as low as 39 and as high as 85, whereas San Francisco's data is all clustered between 57 and 70. Use this information to answer questions 4 through 7 on your independent practice page. Pause the video here until you're ready to move on. When we find the mean of a set of data, we find the average. That average can be more or less representative of the entire set of data, depending on how much variability there is in the data set. The mean we found for San Francisco is much more representative of its average temperature because the temperature does not change greatly from month to month. The mean we found for New York is less representative of its month-to-month temperature because the temperature changes so greatly depending on which month we look at. Look at problem 8. This table shows the time it takes students to get to and from school in both the morning and afternoon. Our first task is to create a dot plot for both the morning and afternoon commutes. Pause the video here as you do that. Calculate the mean of both the morning and afternoon commutes to answer questions 9 and 10. Pause the video here until you have the means. Good work. Both have an average commute of 14 minutes. The last problem instructs us to decide which data distribution is more accurately represented by this mean. In other words, which data set is the mean of 14 minutes more representative of the entire set of data? The data is clearly more accurate in the morning, with much less variability than the afternoon data. Continue to build on our work today as you move through your independent practice.